In this video, we will be learning about properties of matter. The learning objectives for this module include describing the four states of matter, classifying matter as elements, compounds, or mixtures, and recognizing physical and chemical changes and properties. Before we get started on these learning objectives, we need to talk about what matter is. Go to the next slide. Come on. So chemistry is the study of matter, which involves identifying substances, interactions and changes within matter, and investigating properties. Chemists really feel that there's a strong connection between the structure of matter down at the atomic level and the properties of that substance at the macroscopic level. And if we understand how the structure influences the properties, then we are able to design new materials with a specific function because they will have the specific properties that we have designed. By definition, a chemical is any substance consisting of matter. Matter is anything that has mass and occupies space, meaning it takes up space. It has volume. All matter is made out of atoms. And so if you look at this picture here, you can see that there is soda, but within the soda, there are water molecules, there's carbon dioxide bubbles, that's the gas that is the carbonation, and then there's also sugar, this is caffeine, that's caffeine, and then sugar. So there's lots of different substances within this soda. Within your skin, you have DNA. DNA is a very large molecule. And then when you write with a pencil, this is graphite. Well, it's supposed to be graphite in the picture, which is just made out of carbon atoms. And so everything you see in this picture, from the pencil to your body, to the paper, to the pencil lead, book, ink, glass, everything is matter. Everything you can see and touch in this picture is matter. And all of it is made out of atoms. Atoms are just incredibly, incredibly tiny. Those cells in your body are made out of molecules, and those molecules are made out of atoms. But not everything is matter. And so let's contrast with things that are not matter. Energy is not matter. Time, sound, light, gravity are not matter. We cannot feel those things. We cannot pick them up. They do not have mass. They do not have volume. Also, abstract nouns such as love, lies, dreams, those are not physical objects, and therefore they are not matter. If we look at this rainbow here, clouds consist of water, and so those are matter, but the rainbow light here is not matter. That is light. That's electromagnetic radiation that happens to be in the visible region of the electromagnetic spectrum. It is not matter. Since we said that matter is anything that has mass and occupies volume, we do need to differentiate between mass and weight. So if you look at this astronaut here, there's three pictures of the same astronaut. They're exactly the same size. And so this astronaut has the same mass across in each different image. Mass is a measurement of the amount of matter something contains. Weight is very similar to mass, but they are different concepts. So weight takes into account the force of gravity on an object, and mass doesn't. So mass just is constant all across the board, and weight takes into account the force of gravity. Meaning, when you weigh something on Earth, that's what we're used to. And so we might record our mass in pounds or in kilograms and equate that to its mass, but really it's our weight because it's the force of gravity on our bodies. If we take the same astronaut to the moon, we know that the astronauts on the moon, as they're bouncing around, they look like they're bouncing more slowly than they do on Earth. Like they take longer to go up and go down. The force of gravity on the moon is less because the moon is less massive. And so the astronaut on the moon only weighs 16.5% of whatever he did on Earth. But without the moon there at all, the astronaut actually has no weight. And so in space, the astronaut is weightless, but he's not massless. He has the same mass that he did on Earth. So they can have different weights, but they all have the same mass. We also said that all molecules are made out of atoms. An atom is the smallest particle that builds matter. It's really the smallest particle of an element that retains the properties of that element. Atoms can combine to form molecules, and molecules consist of two or more atoms joined by chemical bonds. You can form, so like if we look here, each circle here represents an atom. So this molecule is made out of two different atoms. But since they're joined together, it's like fused balls here, they are one molecule. And so since both atoms are white represents hydrogen atoms. So hydrogen's represented by white. And so we would say that this molecule has a chemical formula of H2 because each molecule consists of two hydrogen atoms. And so that's a little subscript 2 down on the right side of the chemical symbol. It doesn't matter that we have 3 molecules of H2, it just matters that each molecule is H2. The chemical formula here represents one molecule, and subscripts represent how many atoms of each element are in that molecule. O2 is very similar to H2, only oxygen is represented by red. And so each molecule here is 2 oxygen atoms, so it's represented as O2. Phosphorus forms little tetrahedral clusters of 4 phosphorus atoms, and so that's P4. Sulfur forms rings of 8 sulfur atoms, and so that would be S8. And so each molecule here has 8 sulfur atoms. You can also combine different elements together and make what we call compounds. That will be in a later lecture. Each water molecule here consists of 1 oxygen and 2 hydrogens, and so we would represent that as H2O. And then carbon dioxide consists of 1 carbon and 2 oxygens, and so 1 molecule of CO2 has 1 carbon and 2 oxygens. You can also make more complex structures like glucose. Glucose is 6 carbons long with lots of oxygens off of each 1 oxygen and 1 hydrogen off of that. And yeah, so 1 molecule of glucose looks like this.